Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to learn how to find equations of lines that are either parallel or perpendicular to another line and pass through a point that we're told is on the line. So first, a little bit about parallel and perpendicular, a little review. Two non-vertical lines are parallel if they have the same slope. So first, let's say we have two lines, line 1, and it has a slope of m1. And we've got line 2, and its slope is m sub 2. In order for these two lines to be parallel, their slopes have to be identical. Notice that it says non-vertical lines. When we talk about vertical lines, their slope is undefined, so we can't talk about them having the same slope. But vertical lines are indeed parallel to other vertical lines. Horizontal lines would be parallel to horizontal lines. They have the same slope. Their slope is 0. Two non-vertical lines are perpendicular. That means that they intersect at a right angle. And we know that they are perpendicular if their slopes are what we call negative reciprocals. So perpendicular, here m1 would equal the opposite of 1 over m sub 2. Vertical lines are perpendicular to horizontal lines. They cross at 90-degree angles. Let's try two examples where we're trying to find an equation given a line that's either parallel or perpendicular to the one we want, and we know one point that's on the line that we want. So the problem that's listed is problem 5. Find the equation of a line that's parallel to y equals 2x minus 5 and passes through the point 1, 8. The line that it's parallel to, that's given to us in slope-intercept form. So I know the slope of that line is 2. And because it's parallel, we're going to use that same slope. I know that it passes through the point 1, 8, so those are going to be my values for x and y. I'm going to use slope-intercept form. So y equals mx plus b. My value for y is 8. My value for the slope is 2. My value for x is 1. And we're going to try to figure out what b is equal to. So 2 times 1 is 2. Subtract 2 from both sides. And we're left with 6 equals b. So I had a slope. I found the y-intercept. I can write the equation of the line using mx plus b form. Y equals 2x plus 6, putting in 2 for the slope and 6 for the coordinate of the y-intercept. So notice that point is parallel, right? It has the same slope of 2, but it also passes through the point 1, 8. If I put in 1 for x in the original equation, 2 times 1 minus 5 is negative 3. That doesn't equal 8, so it's not on that line. But if I put in the 1 for x and the 8 for y, does 8 equal 2 times 1 plus 6? It does. So it's parallel because it has the same slope and it goes through the point 1, 8. The other problem that we're going to work on is we're looking for a line that's perpendicular to another line, and that line is given in general form. So we've got a little work to do to find the slope. So the first step is to find the slope of the line you're comparing to. The second step is to figure out whether you're going to use that slope or its negative reciprocal, which we will in this case because it's perpendicular. Then we can go to slope-intercept form to finish it out. So first, let's find the slope. We've got the equation 5x minus 3y equals 21. I want to solve this equation for y in terms of x. Subtract over the 5x, negative 3y equals negative 5x plus 21. Divide through by negative 3. And we end up with y equals negative 5 over negative 3 doesn't simplify, except the two negatives can divide out to be positive. Y equals 5/3 x 21 divided by negative 3, that's negative 7. Although we don't use that, This 5/3, that's the slope of the line we're comparing it to. Next, I need the perpendicular line slope. And so that's the negative reciprocal. So when I wrote it originally up here at the top, I said put -1 over that slope. But when you have a fraction, you can just take the reciprocal and change its sign. So reciprocal, change the sign. So we had 5/3. The perpendicular slope, by the way, that's the subscript we use for perpendicular, upside down, capital T, basically. It's going to be 3/5, and it's going to be negative. So another way to think about perpendicular slopes, their product should equal -1. 5/3 times -3/5 is -1. All right, so I've got a slope, and I've got a point, -10, 12. I can go to the slope-intercept form to find the equation. So the value, let's write the formula first. Y equals mx plus b. Y is 12. Equals m is -3/5. X is -10 plus b. Negative times a negative is positive. 5 goes into 10 twice. So -3 times -2, that's +6. I've got 12 equals 6 plus b. To solve for b, I subtract 6 from both sides. 6 equals b. So I found the y-intercept. I have a slope to work with. Now I can write the equation. Y equals -3/5 x plus 6. That's the equation that's perpendicular to 5x minus 3y equals 21, and it also passes through the point -10, 12. Both problems, although the second one seemed more involved than the first one, they both use the same basic strategy. Find the slope first. In the first problem, it was basically given to us because the equation was in slope-intercept form. In the second one, we had to work for it because it was in general form. Then decide whether you're going to use the slope that you found, parallel, or take the negative reciprocal, perpendicular. Finally, substitute into y equals mx plus b, and that will give you your value b, which will lead you to your equation. All right, that's it for this one. I'll see you in the next section.